Hi guys, I want to show you a couple things today because you're going to have some topics coming right up that you're ready to learn in ALEKS, and you just want to introduce you to them before you get to those topics. First thing I want to talk about is what is an integer? So integers are, I can't write them all because they're infinitely many, but I'm going to give you some examples. So integers are whole numbers and negative whole numbers, but not fractions and not decimals. So sort of like the markers, but not the in-between parts. Obviously, if I went this way, I would have -4, -5, -6, -7 forever. And if I went this way, I'd have 3, 4, 5, 6, 7, 8, 9, 10. So if a number can be simplified to be a whole number or a negative whole number, then it is an integer. If it already is one of these numbers, no question, it's an integer. Okay? If a number is a fraction and you can't simplify it to be a whole number or a negative whole number, this is not an integer. If a number is a decimal of any kind and it can't somehow be simplified to be a whole number, can't think of an example where it would. If there's a decimal, it is not an integer. So integers are whole numbers. These are whole numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 forever. And the negative whole numbers. And instead of saying whole numbers and negative whole numbers, we have a word for it. It's called integers. So think integers. Write this down in your math notebook. Integers. Positive. Whoa, that was weird. Positive. You're writing this down. And negative whole numbers. Not fractions and not decimals. Unless we can simplify them. Okay? So if you have a number like, 16 fourths. 16 divided by 4 is 4. So that is, yes, an integer. Okay, that's the first idea. What is an integer? The second idea is this. If I want to solve small equations, let's say I have something like this. 4x equals 12. We do something called the multiplication or division property of equality. What it just means is I want to find something that causes the 4 to go away, to cancel, to just become a 1, so that I can see x all by itself. I want to know 4 times what equals 12. Well, we can see in this small problem, we can think about that. X must be 3, right? Because 4 times 3 is 12. So here's a little trick that you can do to solve these, because sometimes they get a little harder than just thinking about what number you might substitute in for x. I'll show you an example in just a second. If I were to divide, okay, this is 4 times x, and I like to think about it like this. The thing that undoes division to help solve a problem is, or the thing that undoes multiplication is division. And so if I divide by 4, what happens if you have 4 over 4? Well, that just equals 1, doesn't it? And so I would have 1x, or you could think about the 4's canceling, going away, right? And so that's exactly what I want to happen, but here's the trick. It's got to be fair. It's got to be equal, and we must keep everything equal on both sides of the equal sign. So this is like rules in a video game, right? The rule is this. You've got to do to one side what you did to the other side. So if I divide by 4 on the left, I have to divide by 4 on the right. So 12 divided by 4 is 3, and I know that x equals 3. That's super cool. What if the number wasn't so nice? What if it was like 52.579 times x equals 1967.5. I'd be like, ah, no problem, right? All we're going to do is say, hey, do you know what undoes times? Well, division does. So I draw the line. I do this. It cancels. I go like this on the other side. And then they're never so cruel as to not let you have a calculator. And you would just type it in. They're never so cruel as to not let you have a calculator if it's too hard to do by hand or if it's really obnoxious. Sometimes you got to do some stuff by hand just to practice because it's not too hard and it's not obnoxious, so just do it. But in this case, 1967.5 divided by 52.579 is whatever the calculator tells you. Just type it in. It's 1967.5, hit divide, and then type in 52.579 equals whatever that equals. I don't have a calculator handy, so I'm not even going to try because I made up those numbers hard on purpose. Okay, let's just do maybe one quick other thing. What if I had negative, let's say 12, and let's make it a u this time, equals a positive 36. Well, this is times, so I'm going to divide. You know it's times because they're right next to each other, okay? There's no plus sign and no minus sign in between. I'm going to divide by negative 12, okay? Notice that I picked negative because negative 12 divided by negative 12 gives me a positive 1, and I definitely want a positive 1, okay? Every time you see a letter, it always has a 1 in front of it. If you see A, it's a 1A. If you see X, it's a 1X. The 1 can be invisible or not invisible, but it's always there. Okay, what do I have to do if I divide by negative 12 on the left? I must divide by negative 12 on the right. Well, positive divided by negative is going to give me a negative answer. 36 divided by 12 is 3. And so I know that u equals negative 3. Does that seem to work? Negative 12 times negative 3 equals 36. Yay, it does. Cool. All right. So that is called the multiplicative or division. Depends on where you see it in a book. Multiplication or division property. Property just means it's a math rule of equality, and that's because we have an equal sign. The other thing you see is inequality, and that's when you have greater than or less than. All right, so that's a little introduction to a couple things you're about to see in your math. How to solve little tiny equations and what is an integer.